if you take a look at the very initial frames of the simulation, you can see that the tips of the tentacles are kind of getting thrown by their initial velocity. It's kind of subtle, they're not getting thrown very far, but they are picking up some of the motion of the animation via that velocity. But because our vellum source is only added to the simulation at the start frame, that's why we're only getting this velocity inheritance on that initial frame there. So we have to do a little bit of extra work if we want to inherit velocity on the rest of the frames as well. And we should also give ourselves some control over how much velocity we're inheriting, rather than just assuming the full velocity inheritance all the time. So let's go back inside our DOPNet, and then in the SOP solver, where we're picking up the color from SOPs, we can also pick up the velocity. And we only want this velocity to be applied at the first moment when grains activate. So once grains are red and already activated, we no longer want those to pick up any velocity from SOPs because we want that to be entirely driven by the simulation. We only want the pieces that are newly activated to pick up velocity. So before we copy over the color and set a new stopped value in our wrangle here, we can store the previous frame's stopped value first. So right after our dop geometry, I'm going to add an attribute swap. And instead of swapping attributes, I'm going to set this to copy. And the source will be the stopped attribute. And the destination will be stopped underscore previous. I'll rename this node to stopped previous. And then on the grain activation here, we can check to see if the piece was previously stopped, then we will add the velocity. So to check this, I'll just say if stopped underscore previous is greater than 0, then v at v, the velocity, will add the velocity from the object merge that's pointing to SOPs. So let's connect this object merge to that second input of the grain activation here. And now we can add the velocity from that second input. So we'll say v at v plus equals the point attribute from input number 1. We'll look up the velocity attribute from that input for the current point number. And we should also give ourselves a multiplier for how much of that velocity we're going to pick up. So I'm going to add an extra parameter in here. I'll say CHF. And I'll call this velocity underscore amount and multiply that by the velocity that we're looking up from that second input. Hit this button here to create that parameter. And just to make sure that this velocity inheritance is working, let's try increasing the amount to be 3 times what it's actually looked up from that input. Then we can do a new flipbook to see if this is working correctly. And flipbooking our sim with velocity inheritance added via that SOP solver, you can see that we are correctly picking up those velocities from our input. It is pretty extreme and we will need to tone this down, and it does seem to be making some of those explosive glitches a bit worse, but it's alright, we're just doing this as a test now to make sure the velocity inheritance is working, and now we can tone it down a little bit to something more reasonable. But first, I'm actually going to turn our velocity inheritance multiplier all the way down to 0 to see if this is giving us control over the first frame of the sim. So going back to our SOP solver within the DOPNet on the grain activation, turning the velocity amount down to 0 there. And I'm just going to check the ends of these tentacles just to make sure that this is correctly processing those initial frames and that it's not going to only give us control over the following frames. And even with the velocity amount set to 0 inside our SOP solver here, it does look like we may be picking up some initial velocity on the tips of the tentacles here. It's possible that this motion is coming from the wind or the gravity, but we can try turning the velocities to 0 on the SOP input if we want to test it out here. So jumping out of our DOPNet and going to the sim attributes wrangle here, I'm going to try just turning off the velocity by setting v equal to 0. And even though velocity is a vector attribute, it's fine to just set it equal to a single float value like this, because Houdini knows to just set every component to that value that we've indicated here. And with the velocity zeroed out before the sim, I'm going to reset our DOPNet. Actually, let's go to frame 97 of the current sim. And with this sim displayed, let's go to our DOPNet and hit reset, and then watch for any change in the viewport as it resims those frames. And resetting that simulation with those velocities turned to 0 does give us a different result, with the tips of these tentacles not being thrown quite like they were before. So you do need to watch out for the initial frame of your simulations potentially behaving differently than the rest. So similar to the multiplier that we added inside the DOPNet, let's also add a velocity multiplier and SOPs here on our sim attributes wrangle. So instead of setting the velocity equal to 0, I'll say velocity times equals CHF for a channel float parameter. Just like before, I'll call this velocity amount and hit the button here. And I don't feel like we need a ton of velocity inheritance on these grain particles. I'm just going to add a little bit so that we have some influence from the motion of the animation. So on our new velocity amount control here, I'm going to try a value of just 0.15. And because we're now scaling down the velocities before sending them to the simulation, we no longer need the velocity amount control inside our DOPNet. So if we go back inside the DOPNet and in the SOP solver to our grain activation wrangle, this is reading velocities from that grains to sim null, which already has its velocities scaled down. So I'm going to turn this velocity amount up to 1. And then just for an extra note in the reference scene here, I'll say velocity amount not needed because already scaled pre-sim. And with our velocity scaling now set up in SOPs, we can do a new flipbook to see what this update looks like. And now our updated simulation is looking pretty cool with this tweaked amount of velocity inheritance. And of course, you can play around with different amounts of that velocity that the grains are picking up from the sim to tweak it to your liking. We are still running into some glitchy explosive areas, particularly in the body here, where some of those grain particles are really shooting out pretty violently. So we still need to investigate and fix that. But otherwise, this sim is looking pretty nice.